You've probably heard terms like Docker, Kubernetes, containers, pods, deployments. But what do they actually mean? Why are almost all modern tech companies using them? Today I'll explain Docker and Kubernetes in the most simplest way possible. Before Docker, deploying applications was one of the most frustrating parts of software development. A developer would build an application, test it locally, and confidently say it works on my machine. But the moment that same application moved to the testing server, something broke. If it somehow passes testing, it might fail again in production. Why did this happen so often? Because every machine was different. One server might have a different operating system, another might be missing required libraries, another could be running an older version of Python, Java, or Node.js, and sometimes even small configuration differences were enough to crash the application. So even when code was correct, the environment around the code was not. Code alone is not enough to run an application. When developers write software, they are not just writing files and functions. Every application depends on an environment around it. It may need a runtime like Node.js, Python, Java, or .NET. It may need external libraries and packages. It often needs environment variables like API keys or database URLs. And sometimes it also depends on operating system level tools and system packages. All of these pieces need to be present and correctly configured. If even one component is missing, outdated, or misconfigured, the application can fail to start, behave unpredictably, or crash completely altogether. Docker solves this problem through something called containers. A container is a lightweight package that includes your application along with everything it needs to run. That means your code, the required runtime, libraries, dependencies, configuration files, and other necessary components are all bundled together in one isolated unit. So instead of worrying about differences between laptops, test servers, or production machines, you run the same container everywhere. And because the environment inside the container stays consistent, the application behaves the same way no matter where it runs. Think about shipping containers used in global transport. The exact same container can be loaded onto a ship, moved to a truck, transferred onto a train, and delivered across the world without changing what's inside. No one has to unpack and repack the goods at every step. The container stays the same, only the environment around it changes. Docker works in a very similar way for the software industry. Docker works in a very similar way for software. You package your application into a container once and then move it between laptops, servers, cloud machines, or data centers. So you just build once and then run anywhere else. Suppose you build a Node.js application that depends on Node 20 version and several npm packages and also certain Linux system libraries. Normally, anyone trying to run that app would need to install all of those things manually and make sure every version matches correctly. That process can be slow, confusing, and full of errors. Docker removed that problem by packaging everything together into one single container. Node version 20, your packages, the required libraries, and the application itself all travel together. Now, anyone can run a single command, start the container, and the application works the same way every time. Docker became massively popular because it solved real problems that engineers had struggled with for years. It brought consistency across environments, so applications behaved the same in development, testing, and production. Containers could start in seconds, making systems faster and more efficient than traditional virtual machines. Deployments became much simpler because teams could package once and run the same container anywhere. Scaling also became easier since you could launch multiple identical containers whenever demand increased. By solving these everyday operational systems, Docker completely changed the way modern software is built, shipped, and also deployed. But Docker alone was only part of the solution. As companies grew larger, they began running hundreds or even thousands of containers across many different servers. At that scale, managing everything manually became extremely difficult. New operational problems started to appear. Which server should run each container? How do you distribute workloads efficiently? What happens if a container crashes or an entire server goes down? How do you quickly add more instances when traffic suddenly spikes? And how do you release, new versions of an application without causing downtime for users? So Docker could package and run our containers, but managing large number of them required something more powerful. That's where Kubernetes comes in. Kubernetes is a container orchestration platform designed to manage containers at scale. Instead of engineers manually controlling hundreds of containers across many servers, Kubernetes automates the entire process. It decides whether containers should run based on available resources, distributes workloads efficiently, scales applications up or down depending on demand, and continuously monitors system health. If a container fails, Kubernetes can automatically restart or replace it. And when a new version of an application needs to be released, it can perform rolling updates safely with little or no downtime. With Kubernetes, you don't need to manually start and manage every container yourself. You simply tell Kubernetes what state you want. For example, I need 5 copies of my API running. Once you declare that, Kubernetes handles the rest automatically. It creates those container instances, places them on available servers, continuously monitors their health, and makes sure the desired number stays running. If one instance crashes, Kubernetes replaces it automatically. If traffic increases, it can scale up with more copies, and when demand drops, it can scale down back efficiently. The simplest way to understand the difference is this. Docker packages applications into containers so they can run consistently anywhere. Kubernetes manages large number of these containers and keeps them running reliably at scale. So Docker is focused on creating and running containers while Kubernetes is focused on operating them across many machines. So they work together but they solve two very different problems. When you open applications like Instagram, you're not interacting with a single backend application. Behind the scenes, many different services are working together at the same time. There may be separate services for login and authentication, feed generation, reels, recommendations, messaging, notifications, media processing, analytics, and much more. Each service can be developed, updated, and scaled independently. Many of these services run inside containers, while Kubernetes manages the overall system by scheduling workloads, scaling services, recovering failures, and keeping everything available for millions of users. If you're building a small project, personal app, or an early stage product, Docker is usually enough. It helps you package your application, runs it consistently, and deploy it easily without adding too much complexity. If your startup begins to grow quickly, traffic increases, and multiple services need to run across several servers, Kubernetes starts becoming useful. It can automate scaling, recovery, deployments, and infrastructure management. And for large scale companies running many services for millions of users, Kubernetes is often essential because managing that level of complexity manually becomes nearly impossible. A lot of people try learning Kubernetes first because it seems like the most advanced tool, but in many cases, that makes the learning process harder than it needs to be. Kubernetes builds on foundational concepts such as Linux processors, containers, networking, storage, and how applications run inside servers. If those basics are unclear, Kubernetes can feel confusing and overwhelming. A much better path is to first understand Linux fundamentals and then learn Docker, and then get comfortable with networking concepts like ports, DNS, load balancing, and service communication. Once those foundations are clear, Kubernetes becomes far easier to understand and use. So, if we had to summarize everything in one line, Docker packages applications into portable containers. Kubernetes runs and manages those containers reliably at scale, and that's exactly why modern software systems use both together.